Hello, hi everyone. Today we'll be understanding about Apache Iceberg, what are its benefits, and then how we are going to use this Iceberg tables in AWS Athena, right? Apache Iceberg is an open source, high performance table format for large analytics data sets, right? Where you can do your complex queries very easily and then update the data using the merge statements, performing an incremental update from the source system into your data lake onto the Apache Iceberg tables, and it supports quite a few good properties, right? Schema evaluation, it allows you to flexibly change your schema, update the columns, delete the columns, and renaming the columns. Partitioning, so it's like any other a feature in the data lake, right? The normal AWS Athena supports the partitioning, and along with that Iceberg is going to pertain the same property, right? Where it helps you to partition your data based upon the countries or year months, which helps you to run your queries faster. And the main property of Iceberg is to have its ACID transactions, right? It's going to give you all the properties of consistency, atomicity, isolation, and durability, so that the reads writes are going to be isolated, and then the user doesn't see any effect of the read writes and reads. Time travel and data versioning. So Iceberg supports a time travel queries where users can go into the table and see the historical updates of the data sets, right? And they can have a track of all the changes onto the data. Snapshot isolation. So snapshot isolation is nothing but you can see the record changes, right? It's almost similar to the time travel, but you can always go to your previous snapshot and then restore from there, right? If you see that there is a data corruption happened in the current data format or version. And data integrity, optimized query engines. So this is all going to be an additional factors on the Iceberg. Compatibility to the different storage systems, which is Amazon S3, Google Cloud, and Hadoop, right? Hadoop on the sense HDFS, and the performance is always better because you are going to have your format as a Parquet ORC, right? And it's all managed based upon the metadata files, which is underlying the Athena of underlying the storage layer of Iceberg, where these are going to be stored in example S3, right? You will see a data folder and a metadata folder, and all the data will be stored over there. So let's go into the working solution of how we can create an Iceberg tables in Athena and then insert some data into that. So I have a sample syntax here where I have a college name as a database and student is a table name having the three fields ID, name, and department, registering it as an integer string and string. So let's take this syntax and try to create a table in Athena. So I have already created a database which is college, and I'm going to create my table which is student. Yeah, so I have a table created here. You can see it, and let's see how the structure looks in the S3. So I have a pre-existing bucket which is created called as tech input data bucket. So it has created a metadata folder already into the data set, and it started storing the metadata.json, right? So these are the files which is going to capture the actual metadata of your data, versioning, isolation, and acid properties, right? Which helps the users to not see any logical updates onto the data and then have a free smooth of the data visualization. So let's see how we can insert the data, right? That should be an important factor. I have an insert statement which inserts the data into the student table, holding the three columns ID, name, and student. And these are the records. Let's try to insert into this table. Yeah. So data is inserted into this table, and you can see this is similar syntax if you have worked on any relational database systems. Let's query the data. I can see three records holding names of Giant Smith, Elias Brown, and then Brown White, and its departments, right? So now let's manipulate this data using a few of the properties of Iceberg. Let's use an update statement and then see how we can change a department ID using a where condition on ID equal to 2. So if you see the current ID 2 holding mathematics, now I'm going to change it to data science, right? and it's going to be a lot simple using this iceberg, which you can't do it in the normal Athena tables. Update college student set department equal to data science where ID equal to true. And now the change is happened. We can see what is the new data available for ID2. So now we can see for ID2, the data is changed from mathematics to data science. Let's see how we can make it one more statement on the updates. I have another statement where update student set department equal to mathematics and computer science, where the department equal to mathematics or physics, right? So this is going to be one more update statement, and this is going to change my data here, right? Let's execute. And you already have a physics, so this physics has to be changed into mathematics and computer science. And this is very fast, right? As you execute, it's going to do all its complex processing within the backend, and then data gets updated into the table. And I'm going to preview it. Here is the change where physics has been changed to mathematics and computer science. And let's see how does the data storage looks for this table now, right? I have a folder which is student, and I'm going to refresh it just to see the updates here. And this is going to be my actual data folder where the data gets stored, and this is going to store all your data here, right? What has been happened in your daily updates on your table. And this is going to be the Parquet format, a default one in Athena, and you can change it to required formats like ORC. As Parquet supports a columnar format, this is also one of the best way to use this iceberg tables. And if I go back into the metadata, which is holding the changes, it has two formats, which is JSON files and then Avro files, right? So these are kind of a metadata files and manifest files which Apache Iceberg architecture defines, right? And we'll go through this about what is the whole architecture of Apache Iceberg into our further videos. But this is an initial introduction how we can use Apache Iceberg, what are its benefits, right? And let's see it in the another course. Thank you all for visualizing this.